Good morning, everybody. My name is Mark Lepkowitz. I'm a professor of molecular biology at St. Michael's College in Burlington, Vermont. And for 19 years now, every Friday, I've gone over what was covered in the two journals, Nature and Science, which are sort of the two premier journals for scientists, with my class, just simply because I think that, first of all, education should be fun. And second of all, it's just great to read broadly about what happens in the science world out there. So any further ado, let's look at what happened in Science and Nature this week. And oh, and I forgot to mention, this is actually really for my students and for past students, for alumni who I've been hearing from quite a bit. So thanks for your kind words and keep sending those ideas for videos. All right, so let's start off with Nature and what was published in Nature this week. There are some, there's some, just gotta love science. There's some great stuff that came out this week. All right, in case you've been wondering, because I have often wondered as I stare into my glass of wine at 2 a.m. Okay, I don't do that very often, but on the occasion when I have, and I see what they call those, what do they call them? Those tears of wine, those little droplets that fall down my little snifter. The physics of how those form is now understood. And I know you've been wondering, how do those form as you stare at your glass of wine at 2 in the morning? So it turns out, as you guys know, wine has alcohol in it. And as that alcohol evaporates, it is going to pull wine, really the water, up the side of the glass, and it'll be held there through surface tension. And then a battle ensues. And so there's a battle between gravity, which is pulling down, and then the surface tension of the alcohol in the water going upwards. And then if you've ever noticed, it forms this clam shell, and then that clam shell collapses into a drop, which then falls back into your glass of wine. Why does it do that? Why does it form the clam shell and then collapse? There is a tiny, 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 so small we can't see it, shock wave that is formed right at the crescendo of where gravity and surface tension come to the final blow between them. And of course, gravity wins, and boom, you get that tear that falls down. And there you go, science. And that's how you get in Nature, okay? All right, this actually is really fascinating. So vitamin E has gotten a lot of press recently because if it ends up in a vape product as a solvent and you heat it, evidently bad things happen. And now they know at least partially mechanistically why. So it turns out that vitamin E, when heated, turns into a compound that's called a ketene. The ketene gas is toxic, and there you go. All right, and someone has found, this is great, a 25,000-year-old larder made up of mammoth bones. And it was a giant closet made up of mammoth bones filled with food. You can't buy that at IKEA. No, you can't. But if you could, I would. All right, I want my pantry to be made out of mammoth bones. Here we go. So it's been known for a while now that if you consume alcohol while enjoying watching those tears fall back into your wine glass, that it can do liver damage. And if you've ever been around anyone who's had some excessive alcohol, you may have noticed that there's this sweetness to their breath. So that's acetaldehyde, is what you're smelling actually in their breath. And it turns out that that compound is created in the liver, and it actually cross-links and binds to your DNA. So if you don't get it out of your body, it mutates the DNA in your liver. And that is why, of course, for excessive drinking, it increases your risk of liver cancer quite a bit because it's binding to your DNA and causing mutations. So if it binds to your DNA, it has to somehow be unbound. And now they know the mechanism by which it is removed and the mechanism by which the DNA tries not to get damaged in that process, although it's not perfect because excessive drinking does lead to liver cancer. So essentially, you got double-stranded DNA, you got this acetaldehyde binds to it, and one mechanism is make a double-stranded DNA cut, pull the acetaldehyde off, stitch the DNA back together. That is risky business. You do that too often, you're gonna make some errors, and yeah, you don't want to be breaking Humpty Dumpty, in this case your DNA, and trying to put it back together again. So they found a second mechanism that actually seems to be a little bit, the mechanism sort of complicated, but it doesn't lead to double-stranded DNA breaks. And that is why the cancer rate really is much lower than it should be for consuming alcohol. There you go. And I bet there was some selective pressure along those lines, but this article did not address that. Okay, here we go. Brilliant, brilliant study, really insightful and unexpected. I'm gonna go with this as unexpected. So this group of investigators looked at 18,116 individuals. That's a pretty robust sample size, I would say. And they asked a very simple question. So they happen to have some, this is a retrospective study. So these are individuals that they know came down with cancer, and they had microbiomes specimens for them over a long period of time. And they essentially asked the question, could we have predicted the cancer by changes in gut bacteria a while ago? And so looking at 33 different cancers, for some, but not all, there was a signature. That is, there was a change in the type of bacteria in your gut prior to being able to be diagnosed with the actual tumor. For some, but not all cancers. So that's interesting. So definitely suggests that your gut the bacteria that live in your gut are responding to formation of tumors, and they seem to be doing it very early. So it suggests that there's a potential development for early detection there. All right, here we go. This one's very interesting. So I didn't know this, but there is a library of chemicals, and that library is called the Repurposing Focused Rescue and Accelerated MedChem Library. And it's got an acronym that I can't even pronounce. Anyway, but these 12,000 chemicals have already been approved by the FDA for human consumption. And so this is the library of all the drugs that are out there. And what you can do is ask the question, can any of them do something else? So if we already know these drugs can be used on humans for these situations, can we repurpose them for something else? And presumably their toxicity and safety levels are known since they've been approved. So this one group just asked, are there any drugs in that 12,000 drug library that actually could be used as male contraceptives? Interesting, huh? So sort of the male pill. And they actually found 2 compounds which show promise. Long way away from clinical trials. It's not even clear they went into a mouse model yet, but interesting nonetheless. All right, last article, I want to share a screen, and because this will just say it all. Dun, 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 dun. All right, so this is, hold on one second here. This is the title of an article that was published in Science this week, and this is looking at the ACE2 receptor, ACE2 protein actually, which is a membrane-bound receptor in human cells. And this is what it actually looks like right here. This is the crystal structure. And this is, of course, where COVID-19 binds. And because they were able to elucidate at unbelievable resolution what the human receptor looks like, oh, wait for it. I'm gonna get my little highlighter out here. Okay, wait for it. This is structure function at its best. So here's the ACE2 receptor, right? Notice that little pocket right there? See the little pocket? And look at the spike protein. Maybe this one is the best one. See how spike protein is like the perfect match for right there? Structure function. Okay, that's all I got for you today. Once again, my name is Mark Lubkowitz, rising from the ashes like the phoenix as always, and trying to let the crisis bring out the best in all of us. I'll see you next week for Science and Nature.